Okay, another rule for logarithms. This one we're actually going to do a proof of because I think it's kind of fun and interesting and reinforces some ideas that we should be comfortable with. So this power rule for logs is one that we use a lot, and it says that if inside your logarithm you have a power, okay, remember how we talked about this is the base, this is the exponent, but the package together is called a power. Okay, if you ever have a power inside a logarithm, the exponent that's in that power can move to the front of the logarithm. Okay, and this is really a foundational piece to how we solve exponential equations. Okay, this really gets to the root of a logarithm being the inverse operation of exponents, right? So we'll talk more about that once we start solving equations. But let's look at a proof of this. Okay, what does it mean for log base a to have x to the n power in that? Really, what that's saying is if I expand this into a product and I have n of those x's being multiplied together, okay, this is the log of a massive product. And the log of a product, ding, 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 is the sum of logs, even if it's more than one term, okay? So this is however many, we have n x terms in here. So that's really log base a of x plus log base a of x plus log base a of x, right? And we would have n of these terms. And what is repeated addition but multiplication, right? So in other words, what's 2 plus 2 plus 2? That's the same as saying 2 times 3 because I have 3 of these. Well, if I have n of these and I have n of these, that's the same as saying n times log base a of x. So that's where this property comes from, okay? And we, like I said, we use this a lot. Anytime you have an exponent inside a log, you can put that in front. Okay. And what's really important here is that these don't have to match. So if you look back at when we were doing these simple properties or shortcuts before, we had one where we said, if this is a and this is a raised to the n power, then all of this basically cancels and you're left with just n. Well, think about what the product rule or the power rule says. The product rule says if there's an exponent here, put it in front, right? And what would log base a of a be? Well, we have that property too right here, right? So that's 1. So this statement is equal to 1 times n. That's where the n comes in. So there's just one implication of how this works, okay? Just wanted to reemphasize the fact that these don't have to match. So if we look at this very basic problem, anytime you have an exponent inside a log and we're expanding, we're just going to take this, whatever the exponent is, and we're going to put it in front. So this becomes log base a, or 4 log base a of x, right? And there's nothing more I can do because inside this logarithm is just a singular term, okay? I want to be clear. We'll see some of this when we start doing some more expansions, okay? But just as another example, this, let's say this, and this are two very different expressions. Okay, we have to be careful about this. So inside this log, okay, is a product. One of the pieces of that product has this 2 as an exponent. So I can't move this 2 in front of this log because it's not an exponent for everything in here. So I mentioned in a previous video how important parentheses are. So in this logarithm, what's inside this log is a power, right? The parentheses are here. Goes back to when we were talking about exponents, and I used to say that the exponent is only the exponent of what it touches or what it's closest to. So this 2 is the exponent of this product. So this 2 can come in front of this log, okay? And I'd still have the xy. Now, there's some more stuff that can happen here. We'll talk in greater detail about expansions later. I just wanted to emphasize this point. In this problem, this 2 is only the exponent for the y. So I'm not going to drop this 2 in front because it's not a power that's inside here. it's a power and a product. This is a power that can get moved down in front. So it's really important we understand how crucial these parentheses are to identifying what the exponent is for. If it's for everything like it is here, I can move it down in front. If it's only for a piece of what's inside the log, I can't do that yet. Okay, but again, we're going to talk about how to expand something like this in a future lesson. Right now, we just want to focus on the concept of this property, which allows us to take an exponent, move it down, as long as it is the exponent of everything that is inside the log. And this is just x, right? That's why the 4 can come down in front.